Okay, folks, this is the setup video for the third lab, the Heinz lab, which is the important lab in the context of the first VBA assessment. So it's just a little bit of a warm-up here, tell you the problem. Again, it's a differential equation with initial conditions, so-called initial value problem. And the two problems we're going to look at is something falling with drag proportional to the speed squared, and a cylinder that is training. The description here we'll probably see in this setup. So okay, let's just say what it says. So Heinz method starts by choosing a step size and say 0.2 and puts ticks along the x-axis. So our x-axis in the problem we're going to look at is going to be time. So this dv dt is like dy dx, so our x is t and our y is v. So if we're to put ticks, it's starting from the initial time of 0, and let's say it'll be 0 plus 0.2 plus 0.2 plus 0.2, etc. And we're going to want to continue along for a certain time up to a final time. Okay. Okay. Given an approximation, which will be going here. So initially we'll have, I think, initial velocity of 0, I think. So this is an approximation. Heinz method produces a rough Euler method predictor. So this is going to go here. So you're going to have a rough predictor here, which has no initial value, a predictor of what's happening at the next point. And then we're going to combine two slopes, one from the previous point and one from the predicted next point. One, it should go in here as well. And we're going to take those two slopes and average them out. And then we're going to continue in this fashion. Okay. So you do a predictor. So this predictor jumps off this. And then this one is our next V. It uses this point. We'll try it again. And no, it won't work. And this point as well. Okay. So I know we're using the word, we're just setting this up. Remember, we're not going to do everything here. On a worksheet, we can solve a specific problem. So if blah, 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 label column A with T and input values from 0 to 20. We went up to 10, I think, so we'll keep on going. This is just in Excel initially. Or you can do that, that's your job. Label column B here, yeah. Label column C, V predictor. C2 maybe left blank, yeah. In cell 3, write Excel code that uses this data, the T0, V0 data, give an Euler method approximation to V at this time. So this is the first predictor. So Euler method is, I'm not going to write the proper thing, we're just setting it up, is equal to previous V, which is B2, plus step size, which is 0.2, times previous slope. And the slope is 9.81 minus 0.0025 times V, and its previous slope, so previous V, times, and to do absolute value, ABS. Okay. So this is your Euler predictor, and now what you're going to do here is in cell B3, use code that does Heinz method. So Heinz says the next is equal to the previous plus the step size, so that's same. And now what you're going to do is you're going to average two slopes. Previous slope plus the predicted next slope. I'm just going to put a 1 in there for now. So the previous slope is this yoke. And the predicted next slope, so that's one slope plus the other slope. So the first thing I did was this, the previous slope, and now I want to do the predicted next slope. So the question for you is, what goes in here? Okay? Because that's not right as it is. So I'll let you try and finish that yourself. And now we're going into the VBA. Name VBA. Okay, so again we're going to have a dashboard. So we'll put the dashboard here. We want a program takes as input. So step size is going to be an input, final time is going to be an input, drag coefficient, mass, initial velocity. Okay. I think that's all we have as input. Okay. And the way we're going, and what you're going to do is you're going to do Heinz method to approximate v, which goes here, for time going from 0 to a final time. I might just delete this here to give more space. Okay. Right. The important. Okay. So let's set up our code. What we want with this, we'll just set this up with the same values as before: 0.2, 20, 90, 0.225 maybe, and the initial velocity say 0. So what we want to do here is to be able to change the values on the dashboard and then just press the button to run it. Inserting the button, the ActiveX control button, sets up your code well. The only thing you really have to add here is option explicit. Okay, so the 4 stages of our code is the following. Define variables. This is going to be the whole way through the module. Initial values. Every variable usually gets an initial value. The exception this time is going to be the predictor is not going to take initial value. And then a do loop. And we can go to the pseudocode. So the pseudocode says do stuff and say maybe loop until condition. That's what our pseudocode will say. And the stuff, each of these is going to be aligned. If you print the time, print the v, so it's dv dt. So what am I on about here? dv dt says like y and x. We will have to calculate the next t. So okay, in terms of the do loop, the first thing is print current values and then calculate next value. So this is all of our programs will be like this. Define the variables, give them initial values, and then a do loop that prints the current values and calculates next. So calculate next t, let's calculate the v predictor, calculate v that's using Heinz method, and you also have to up your counter. The variables you need here, the most important ones are is velocity and time in terms of the method, v predictor, and then in terms of the input, h, final time. What else do we have? C. That's it. Is there anything else? The dashboard, h, final time, c, and that's everything. Okay, and then you'll need a row counter. Give them all initial values from the dashboard. Do your printing. Calculate your next printing, and see how you get on with these. The idea is that you'll give them a bash. Hopefully you got on okay with this, and you'll be able to give the thing inside a bash. Okay. We're also going to set up the next one. I'm just going to copy this code. It's going to be very similar. I'm only giving you not very much on the setup. So I have the exercise. Okay, so this one is this, so dx dt, so it's like dy dx. So the x, t is playing, so dx dt is like dy dx. So the role of x is being played by t and the role of y is being played by x. Okay, in terms of dashboard, what is the inputs? Well, h, final time. This is set up funny by me. Little r, big R, and I think the initial height. I think they're the things I need. Insert ActiveX control button. I said I was going to copy paste what I had. I was also going to do option explicit. The variables is the xdt, so x is the most important. I'm also going to need next predictor. HTF C. Now here there's a little r. I'm going to go with little r, and I'm going to go with big R, because I'm going to keep my. It's a bit confusing. Could I change this to RW for row so I don't get too confused? Okay. You're going to print T. You're going to print X. Calculate next T. X predictor and X. There's other stuff to look out for. Beware. X predictor going negative. You get a mathematical error. And then here, note if X goes negative, then that's saying the height of liquid is negative. Then if the height of liquid is negative, tank is empty. Okay, so this is your setup. And then just the last thing, just to point out, when you're finished, you can have a look through this section 3.4, which is giving you accurate information about your BPA assessment, which is based on this lab. So this is your basic setup. So hopefully you'll be able to have a bash from there. If not, have a look at the next video.